Hi everyone. Today we are going to talk about thinking from first principles with a practical taste. I'm Rukshan Senanayaka and we're going to talk about this with these key topics. First, we are going to have an introduction to what is first principles thinking, and then we are going to take a look at a coding example problem, and also we are going to try to solve this problem using the traditional approach and also using the first principles thinking approach. And finally, we'll have a comparison between these two approaches and define why the first principles thinking approach is better. So what is first principles thinking? It's a powerful approach to problem solving that breaks the problem into fundamental elements. So this is the key aspect of first principles thinking. Now, when we come across various problems in our day-to-day life, and of course in software engineering, these problems can be very complicated and complex. But similar to what we were doing when we were kids, playing with building blocks, these complex problems have been caused by fundamental elements or components. So if we pay attention to these fundamental elements or components, we can solve problems no matter how complex they are. So this thinking from first principles fosters innovation by challenging assumptions and finding transformative solutions. Because with the advancement of knowledge and technology, people abstract away and assume some things as trivial. For example, we almost always hear the phrase, "Don't try to reinvent the wheel." Now in software engineering, this is very common because there are so many packages, libraries to solve common problems. But when it comes to complicated situations or where we need to optimize something or make something efficient, it is very useful if we have this thinking from first principles within our toolbox as software engineers, because then we can challenge these assumptions. And when we challenge these assumptions, we have the opportunity to solve some gaps that were in the original fundamentals that were established by somebody or some set of people. So trying to understand this concretely using a coding example, let's take this very simple example of creating a simple text animation. Now the problem to solve here is we need to have this hello world message animated when I click this toggle animation button. Now when we think about this solution, when we think about this problem, it seems very simple. But I took this example to have the idea of first principles thinking in a more concrete and clear way. So when we have the first principles thinking approach to solving such a simple problem, we can use the same approach to solving complex problems no matter how complex they are. So the main requirements in solving this problem is we need to create a simple text animation, and also we need to animate the text fading into the weave. Now how can we solve this using the traditional approach? You might have well thought of it. If you are using a framework like Next.js, there's a lot of packages available. For example, there's a UI framework or a toolkit called ShadCN. I'm sure you've heard of it if you are into front-end engineering. So what we can do is maybe use ShadCN or Tailwind CSS and just easily create an element within your DOM, within your HTML, and just have these utility classes take care of the animation and all this stuff relevant to that. Now, what is going on when we are doing this traditional approach? Here, you are assuming some things. For example, you may have an animated text component from ShadCN or some other package or a library that you don't know the internals of how it works. You can just abstract away the complexities and think, okay, this is an animated text component. And in fact, in our coding example, you can see I just have this animated comparison, and inside that I have this card content, and there I have this tab content. So this is where the actual code that I'm going to show you here, this is written. So here we have just a text component and a button, And if I click this button, what happens is this text will fade in and fade out and toggle between those two states. Simple enough, right? So the way that it works is by using Tailwind utility classes. Now I'm sure you can see here. So I'm using a Boolean variable to check whether it's fade in or fade out, and then accordingly assign whichever utility class is needed from Tailwind side. Now what happens underneath is not known to us. So we are, of course, you're putting some utility classes, and then we are expecting it to behave the way that we want. Because why? We assume Tailwind CSS will take care of the actual CSS. What if that assumption is wrong? What if the developers who develop Tailwind CSS have done a mistake? Which is obviously possible. We are all engineers and we are all human at the end. So it is very possible that although unlikely, it is theoretically possible for some engineer at Tailwind CSS to mistakenly code one of these utility classes. Now as the end developers who are using Tailwind CSS, we assume the utility class to behave the way that we want, and we just use it in our software. But this is the key problem when we are not using first principles thinking. The assumptions that we make have the room to be incorrect. If it is in fact incorrect, then the problem we are trying to solve will not be solved the way that we want it to be solved. Let me repeat that. Without using first principles, if you are using the traditional approach to solve the problem, we do make assumptions. For example, in this case, I assume the Tailwind CSS classes to work correctly. But what if they don't? If they don't, my problem, which is initially I outlined my problem, which is to animate the text. So this problem won't be solved if my assumption is wrong. That is the key problem with this traditional approach, where we make so many assumptions in solving a problem. Now, these assumptions may play out well in most of our problems that we need to solve as software engineers. That's why we use packages and libraries all the time. But when we are faced with a complex problem, it is always good to think in terms of the fundamentals or the fundamental elements that this problem is made of. Now, what does that mean in terms of the context of this concrete example? So let's think about the first principles thinking solution. Now here we break the components of this problem, which is, again, I remind you, the problem is to animate the text. So we break the components that are causing this problem, which in this case the text itself, the time dimension, the distance, the animation math function, which is easeIn for now. We don't need to get into the details, but there is some function called easeIn, and then the opacity value. These key components are what contributes to the problem that we have at our hand. And if we were to solve the problem the way we want, we have to think about these components individually. What does that mean? So here we can just toggle the animation using the black box approach or the traditional approach. Now if we move on to the first principle, you can see each of the components that are contributing to the problem are displayed as separate fields. For example, the text itself, I can just change it and you can say it is updated. And also the transform distance, which is the distance to which this animation is taking place, and also the duration, and also the timing function. So when I change this, you can see the problem takes a different shape. Now if we want to have hello world, of course we need to change the text to this. That's how we solve the problem. How did I know I need to change the text? Because I have identified the components of the problem. I grant you that what we have is a very simple and a very trivial problem, but when it comes to complicated solutions, when it comes to complicated problems as well, these key components will be the same. I mean, we have a complex problem, and then we have the key components contributing to that problem. So these key components are what we should be paying attention to if we are going to solve this problem. So if you want to, for example, let's say I want this animation to be faster. Do I need to change the text? No. Do I need to change the transform distance? No. The timing function? No. Then I should be changing the duration. Let's change it to 100. And now you'll be able to see the animation is a lot quicker. So that is the way, like the engine, wheels, the transmission of a car makes the car, we need to identify the components of a problem. So this is first principles thinking. Now if we go into the code of the first principles thinking approach, you can see that we are putting the different fields, and then we are using the animations to make them happen. For example, if we go into the if we go into the set distance, we can see, and then the distance will be used. So here we are using the style transformer and then style attribute, and then we are using this to have the opacity, the transform position, and the which sort of transition we need. So right now then we are not using any tailwind for this one, so the assumption is removed, but still we get the problem solved. Now in the worst case that tailwind people have made some sort of a mistake, still our problem will be solved because we have used the first principles thinking. We did not make any assumptions. Moving on to the conclusion. So this first principles thinking comes in handy in software engineering, but it's not limited to software engineering only. For example, the famous Feynman technique by Richard Feynman has some commonalities with the first principles thinking. And also, if you're up to date with aerospace news, you might have seen the news where SpaceX agency of Elon Musk have developed reusable rockets. Now, he mentioned in one of his stories that he tried to understand what are the fundamental components of a rocket. And that's how he came to know, okay, this is something that I can do. We used to say it's not rocket science, meaning that rocket science is very complicated. In fact, it may be, but if you're following this thinking from first principles, it doesn't really matter how complex a problem that you're trying to, it doesn't really matter how complicated of a problem that you're trying to solve, because you will be breaking down it into the fundamental components and thereby trying to solve for each of these fundamental components and then aggregating them together to solve the actual complex problem. So I hope you got some insights into thinking from first principles with a practical test using a simple code example. But I think this will be helpful for you to learn more about this thinking from first principles and apply this when you are solving complex problems in the field of software engineering. So if you got something from this presentation, that's a pleasure of me, and make sure to like, comment, and also please share your ideas and interpretations of this, because I'm also learning. I would like to hear your ideas and thoughts on this matter as well. So subscribe, like, comment, and share.